Number 8. Given a function f of x is x squared minus 2, that's a parabola, move 2 down, and g of x equals x minus 2, that's a line, also moved 2 down. Find the composition f composed with g of x, or fog of x, and tell me its domain. Tell me the inverse function, f to the negative 1 of x, and its domain, and tell me whether the functions are either odd or neither. So I really think I should think about the graphs first. So x squared minus 2 is this parabola. Its domain is x is greater than or equal to negative 2. No, that's not true. Its domain is x can be anything, and its range is y is greater than or equal to negative 2. And g of x is x minus 2. Its domain, x can be anything, negative, positive, 0, and y can also be anything. So we're on pretty safe ground here. We don't have any strangeness with domain and range restrictions. Okay, fog of x. That's f of g of x. So we take this rule that f of x gives. It says take what's in my parentheses, square it, and subtract 2. What's in my parentheses is g of x. So it's x minus 2 gets squared, and I subtract 2. Now when I write compositions, I need to write them in polynomial form. So multiply this out. Be sure you remember this middle term. You might want to do the rectangle. Minus 2. And then we simplify that. X squared minus 4x plus 4 minus 2 is plus 2. What's the domain of the composition? The domain includes the domain of the inner function, x can be anything, and the domain of the composition, which is still x can be anything. So what's the domain of the composition? X is anything, or from negative infinity to positive infinity. All right, second piece, the inverse function, f's inverse of x. All right, and when we look at the graph, the inverse is going to be the reflection of this graph in the line y equals x. But this line is not a one-to-one function because it fails the horizontal line test. So I need to limit my domain either to x is always positive or to x is always negative. So let's do the algebra to find out what the inverse function and then find out what our domain needs to be. Okay, so to find the inverse function, I write down f of x equals x squared minus 2. Then I let f of x equal to y. Then I switch x and y. And my last step that I do is to solve for y. So y squared is x plus 2. So y has to equal the positive or negative square root of 2, and that's not a function. So let me just choose the positive square root of x plus 2. So I have chosen which side of the function I want to write as the inverse. Now an inverse function will look, this inverse function will be the square root of x plus 2, and that's a square root function. Move 2 to the left, so that's at negative 2. So this point is 0. The square root of 0 plus 2, which is root 2. So which branch have I chosen? I've chosen the one on the right hand side. So what's the domain of my function? x is greater than or equal to -2, which you can see from this, because for any square root function, what's under the root has to be positive. For x plus 2 to be greater than or equal to 0, x has to be greater than or equal to -2. All right, lastly, are they even or odd or neither? Well, let's look at f of x. Is it even or odd or neither? To find out a bit about even or oddness, I substitute -x for x, and I see what I get. Okay, -x squared is -x times -x, which is x squared. Ooh, and that equals f of x. So f of -x is equal to f of x, and that makes it even. Let's take a look at the graph. This graph of x squared minus 2 is symmetrical about the y-axis. I could fold it on the y-axis, and the right side and left side meet, so it's even. All right, let's take a look at g of x, which is x minus 2, and do our even-odd analysis. So I substitute -x for x, and I get -x minus 2. So that's the negative of x plus 2. That's not equal to g of x, and that's not equal to the opposite of g of x. So that means it's neither even nor odd. Neither even nor odd. Let's take a look at the graph. Clearly, if I fold it in the y-axis, it doesn't reflect, because if it folds in the y-axis, the reflection would look like that. It doesn't happen. Also, if I rotate it through 180 degrees around the origin, that is not the same as the original graph, so it's neither even nor odd.